Okay, we're going to start with number 1 on the 2019 AP. We're going to do the calculator problems. I just tested this out to see which would end up being the best way to do this. What I'm going to do is we're going to set up all the problems, and then I'm going to do the calculations using the calculator, but all at once. And the reason is that the display of the calculator on the screen at the same time as the paper doesn't work, but it's okay. We'll see what's going to happen from there. The big key to problem number 1 is going to be something like this. If we integrate rates, we get back quantities. If we integrate quantities, as an example of that, if we integrate meters per second, we get back meters. And if we integrate, quantities, if we derivate quantities, sorry about that. If we take the derivative of meters, we end up with meters per second. So there's always going to be a problem like this one on here, which is things are coming in and things are going out, and they're going to ask us about finding different information about it. So we've got here a fish entered the lake rate. This is the rate they come in. The rate is, I'm going to write down the equation. E sub t equals 20 plus 15 sine pi over. And they're going to give me the units of measure for these rates. The rates are measured in fish per over the 5-hour period. T equals 0. Give your answer to the nearest whole number. So which of these? 0, 2, E sub t for the fish that were in there. Up, divided by either at the top here. Would be when the rate of change is equal to 0. Now, the rate of change of fish in the lake would be the rate of fish coming in. That's E sub t minus L sub t, fish going out, and I have to see when that value is equal to 0. I'd find the time for that, and the way we're going to do that is we're going to graph that coming up when we do all our calculator parts of our problem. Right there, we'll see where that graph has a maximum on the particular graph. And the last part, D, says, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? So I hear increasing or decreasing at t equals 5. So we want to know if the rate of change of the number of fish is increasing or decreasing. So we want to look at the rate, if we wanted to look to see if the rate of change is increasing or decreasing, I would have to look at the rate of change of the rate of change, actually, so D. So I would have to see what's going on at E prime of 5. That's going to tell me about the rate of change of the fish coming in. The acceleration of the fish coming in. I would have to look at L prime of 5. And I have to see what I'm going to get for E prime of 5 minus L prime of 5. If the answer is positive, then it's increasing. If the answer is negative, then it is decreasing. So we're going to put all those in the calculator in just a moment and find out our answers and see what we get. Okay, hang on a second while I get the calculator on screen and in view. Okay, so there are several ways to do these problems. Whenever I'm going to work on a problem, I'm always going to add a calculator page, and I'm going to add a graph page, both. And I'm going to check now to make sure I'm in radian mode on both. If I'm not in radian mode, and I am in radian mode on both, I'm going to default my calculator to radian mode, which we will do together at a different time. But here we're going to go to the Gears of War, we'll go to Dock and Settings. Put your display digits on fixed 4. If you haven't, it's going to give us enough decimals to always work this problem. My angles are in radian, and I can choose make default even though mine is done already. I'll do it again. Okay, so now there are several ways to do this problem. We're going to start A, because we have the math we're going to do right here. I'm literally just going to put this function into the calculator and get an answer out. So it's menu, calculus, integral. I'm going to go 0 to 5 of 20 plus 15 sine fraction tool pi times t over 6 dt, because t is the letter I'm working with. I'm going to hit enter. Then I'll hit control enter to get a right answer. 153.45. They wanted it to the whole fish. So my correct answer here is going to be 153 fish. Oh. I know I kind of squeezed it on there. It's because I worked with the, I don't have to put in the units of measure. Remember, if I have t in here, in the equation, I can put t into there. I'll explain why we might do it differently in just a minute. The next question is having me do the same thing, but having me do it with, whatchamacallit here, with the integral of L of t. So I'm going to go to the integral, menu, calculus, integral, from 0 to 5. L of t is 4 plus 2 to the 0.1 times, make sure you use that times tool, t squared dt, and I got 30.2952. I'm going to write down 1 over 5 times 30.2952. Remember, when you're finding an average, you're dividing it by the length of the interval. I got 6.05, and how does it ask me for this? It asks me for it to the doesn't give me a where to round it to. If it doesn't tell us where to round it to, we're rounding it to the thousandths place. So this would be 6.059. If it does not ask me for units of measure, I am not putting units of measure in there, so I'm not going to do that. Okay, part C. Part C asks me when the graph is at a maximum or a minimum. As soon as I hear max and mins, I'm going to graph the slopes. Okay, so for part C, I want to know where the graph turns around. Where the number of fish turn around. So what I have to look for is where the rate of change of fish is equal to 0. Now, this is the classic AP thing right here. The function I have, E of t, is the rate of change of fish. That's in and out. So I want to see when the rate of change of the fish coming in minus the rate of change of the fish coming out is 0, and that should be my time when the graph is at the maximum. Now, the way I'm going to do it is the following. I'm going to go to my graph page with the tab button, and I'm going to enter both functions into the calculator. You don't have. So I've done this. I've entered this into one, and you notice I've now changed the t to x. I'm using x as opposed to there. I'm going to get the second function. I graphed the two of them there, and then to find the difference between the two, I graphed f of 1 of x minus f2 of x, which is e of x minus l of x. To get the f1 and the f2, it's the var button on the keyboard, and you can see those functions will come on up. So the question is when is f of 3 equal to 0? Well, f of 3 is equal to 0 at these random points back here, which are negative values. Let's find this one right here by going menu, analyze graph 0. I'll start on this side. My mouse keeps clicking. Menu, analyze graph 0. I gotta click on the graph I want, which is this one. Go to the left of it. Go to the right of it. And there's my time, where the slope of the graph would be 0, because the values of this graph are the rate of change. It would be 6.2036. And what units of measure do we want this to? So they don't tell me, so I have to round to near. So it's 204. That's when the maximum number of fish are in there. The other way you can think about it, number of fish in there are the area under this curve. And the area under the curve is increasing all this time here. The black curve is increasing all this time here until right there. Once it drops below, it starts decreasing. That's why it's there. So the other thing about having them in the calculator, in terms of having the functions graphed, is I could have done the first two parts of the problem by just using the f1 of x. You don't have to. You can do it either way. I could have gone for the first part. I could have gone menu, calculus, integral, 5, var f1 of x, and I would have to go dx. Because when you use the graphing thing, you have to use the x key as the tool, and you'll still get the same answers I got from before. Okay, let's take a look at the last part. And the last part says the rate of change increasing or decreasing. To know if something's increasing or decreasing, we look at its slope. Oop. Go back over here for a second. We want to know if anything is increasing or decreasing, we look at its slope. We want to know if the rate of change, which is e, so t minus L, so e prime of t, minus L of t. So how are we going to do that? We're going to come to our calculator. And I can go derivative at a point. Going to be at, we'll hit enter. I would say e prime of, we're going to see if there's a lot that says, hey, here's what you're starting out with.